Okay, hi guys. I'm sorry to become a little late. So let me share my screen 1 second. Okay, so hope you're able to see my screen, people.
Yes.
Okay, okay. So yeah, so if you can remember, right? So we were seeing about Born-Haber's cycle, right? Can someone tell me what was Born-Haber's cycle used for, people? Hello, hope everybody's there. In the chat box. So yeah, almost everyone is there. Okay. So what I'm asking is, we were doing Born-Haber's cycle, if you can remember, right? So can what was it about? What did we use Born-Haber cycle for?
Like the principles, sir, used it.
No, no, not the principle. What is it used for? It is used to find out
Increasing
something, right?
energy released.
No, the overall interest of what? What did we find out at the last at the Born-Haber cycle?
Enthalpy.
Sorry.
Lattice enthalpy, sir.
Correct, correct. Yes, we are. That is what that was used to find the lattice enthalpy, right? So there is no direct way to find the lattice enthalpy, right? So what we did, so basically, our Born-Haber cycle says that in a process, right, in a process, the amount of energy released is equal to the amount of energy absorbed. That's the simple way of putting Born-Haber cycle, right? So we said that, say, if I have a sodium chloride to be formed, first I have to convert sodium solid to sodium gas, and then sodium gas to sodium plus. So all these again, so same way in chlorine, right? So all this has to be converted, and then eventually, when you form the Na plus and Cl minus, when they make the lattice, right? When they form the structure, the energy released is what is called as the lattice enthalpy. Is that right? Okay. So obviously, and we said that we put all the energy absorbed on one side, all the energy released on another side, and we know all the other enthalpies, all the other energy transitions, right? So with all that information, we'll be able to find what is the lattice enthalpy. That is what we have been doing, right? Okay. So that's about, we have completed all the enthalpies, people, right? So what we'll do today is we'll do some problems, okay? And then we'll quickly go for it. Right? We just have very last part of the chapter remaining. Just give me a moment.
Sir,
Yeah.
sir, for me some pencil kind of icon is here, sir. I
Pencil kind of,
unfortunately clicked icon is in my screen, sir. I unfortunately clicked it, sir. I
okay.
don't know what to do, sir.
But nothing has have happened in my screen.
Oh, I thought I just do something now, sir. I had some pencil kind of icon
Oh
within
yeah,
my
that is
screen. I
that is your
clicked it, sir.
annotations. Yeah, yeah, no problem, no
I
problem.
yes,
So
sir.
maybe if you try to draw on your screen, maybe I'll be able to see it in my
Yes,
screen.
sir. I
Actually.
did it unknowingly, sir. Not wantedly. I just clicked it. I got, sir. I am attending from a tab, sir. Usually I
Okay,
attend
okay.
from a PC, sir. So I clicked it because it is new, sir.
No issues, no
If
issues, Pranav. No
anything
issues,
happens,
no,
sir.
no issues, no issues,
Okay,
man.
sir.
Right, no issues. Yeah. Okay, so we'll go about the problems. Okay, stylus. Yes. So I'm gonna give you, yeah. So they have given this. I have O3 gas forming O2 gas plus oxygen atom gas, and they have given the delta HR, that is for this reaction, is 106.5 kilojoules per mole, and they have given enthalpy of formation of O3 gas is 142.7 kilojoules per mole, right? So they are asking what is the bond enthalpy of O double bond O in O2. Okay, so they have given the reaction, right? And they are given the enthalpy of the reaction. And then one more information given, they have given the delta HF, that is the enthalpy of formation of O3 gas, right? And they're asking you, what is the bond enthalpy of OO double bond in O2, right? Fine. So I'll give you a minute to think about how are we going to go about this problem. Guys, and please be okay with this. I'll be taking at least till 8:10 today, right? Because we started late, even though it's my mistake, right? But I had my things, right? So please bear with it. Right. So any idea how to go about this problem?
For del HR, we can
Hmm.
use that formula thermal. So with bond enthalpy of reactant minus bond enthalpy of product.
Yeah, that we can do. But for that, we require O3's bond enthalpy also. And if you can see here, I have oxygen atom, right? How will you speak about bond enthalpy for an atom? What bond is there to break, right? In this oxygen gas, that is oxygen atom gas, right? There are no bonds to break as such, right? So yeah, so how will you go about it? Anyway, okay, let me help you in this, right? So please see, look at this. They have given delta HF of O3, isn't it? Delta HF of O3 is given, and they have given the total enthalpy for this reaction is given, right? So I can write this delta HR, which is here, as delta HR, or whatever the value is, doesn't matter, right? So now how will I write it in terms of enthalpies of formation? You tell me. For this reaction, how will I write the enthalpy of formation in terms of delta HF? You tell me. What do we generally do? Like the overall enthalpy of reaction in terms of enthalpy of formation, how do we do it?
We write it in the most stable form of.
No. I'm asking, right? We have a way of doing it. We have total enthalpy of formation of products minus total enthalpy of formation of reactants. Yes?
sir.
Yes, that we can do, right? So how will I write it now? I have enthalpy of formation of oxygen gas product plus, what about O2? What is the enthalpy of formation of O2 gas? Sorry? What is the enthalpy of formation of O2 gas?
2 times del HFO.
0, right? Why is it 0?
How 0, sir?
It's in the stable form already, sir. Natural.
Exactly, right? I told you, whenever you see elements in their stable state, O2, H2, N2, sodium in its elemental form, all these, I told you, we even wrote a note, if you can remember, right? Enthalpies of formation of elements in their stable state is 0. Obviously, oxygen gas is not the stable state. O3 is not the stable state, but O2 is, that is how it's available in nature in the stable state. So obviously, enthalpy of formation of O2 is 0. We did this lot of times. You have to remember this, people. Whenever you see elements in their stable state, right, their enthalpy of formation is 0. Please remember this. Is that cool? Right? Fine. So what I was telling? Okay. So again, the products are over. Enthalpy of formation of O, which we don't know, right? Minus enthalpy of formation of O3 gas. Is that cool? Right? So enthalpy of formation of products minus enthalpy of formation of reactants. In the products, I have oxygen gas and O2 gas. Right? Oxygen gas, obviously we have to put some value. For O2 gas, it's 0, and on the reactant side, I have O3, ozone. Right? Fine. Now this value is given to me. Is it not? Delta HR is given to me. So that is basically going to be 106.5. Yeah, 106.5 is equal to enthalpy of formation of oxygen gas minus 0 plus 0 minus whatever the value which is here. I have enthalpy of formation of O3 to be 142.7. Right. So with this, obviously, I'll be able to get what is the enthalpy of formation of oxygen atom. Yes, any doubts?
No, sir.
Okay, fine. So cool. So this is okay. So I'll be able to find what is the enthalpy of formation of oxygen atom. Right. But what they want to find, okay, now people, how will it find? Okay, this is okay. Now people, actually wish I should have done it in a little different way, but still works. Now, if I want to find bond enthalpy of O2, right? So if I say bond enthalpy of O2 is some X, how will I write the reaction for this? For this particular enthalpy statement, how will I write the reaction? What? You don't have to think so much about it. How will you write it? What is bond enthalpy? Bond enthalpy is basically enthalpy of atomization, right? Okay, so how will I go about it? How will I write the reaction?
O double bond O.
Doesn't matter. O double bond O or something. Okay. Okay. Tell me. O double bond O gives. Okay. Fast of all. Right. Now let me ask someone. I need to ask what exactly is bond enthalpy. Right. So maybe Divya, will you be able to help me define bond enthalpy? We gave a statement for bond enthalpy or enthalpy of atomization, isn't it? Can you tell me what is that statement, Divya? Divya, are you there? If not, please find me in the chat. Are you there in the chat? No. Okay. So maybe I will ask Rahul. Are you there?
Yes, sir.
Kana, can you tell me what is the statement for bond enthalpy? In the sense, the definition of bond enthalpy. We gave a statement, right? Do you remember the statement, Rahul?
Yes, sir.
Yes. Can you tell me the statement?
It is the enthalpy change occurring when 1 mole of a gaseous compound is converted into its element in gaseous atomic phase.
Into its elements? Did I say elements?
Yes, sir. Elements.
Is it elements or atoms?
Sir, the elements only, sir.
Sir,
elements. Oh, okay. Oh, elements in their atomic state, gaseous atomic state, I was told. Is that it?
Yes, sir. Gaseous atomic.
Okay, then it's fine, right? So obviously, what you have to convert? You have to convert a molecule into its atoms. Is that it? That's the simplest way of putting it, right? Thank you, Rahul. Right. So now everybody had heard the statement, right? So now can you tell me how do you go about this? I have O2 molecule. So what should I convert it to?
To its atomic state.
Exactly. So now tell me the reaction.
O plus O, sir.
Yes, that's it. So I have O2 getting converted to 2 oxygen atoms. That's it. O2 gas gets converted to 2 oxygen atom gas. That's it. As simple as that. Is it not, people? Was it so difficult? Right? So now hope you understood whatever it is. Right? So when I say bond enthalpy of O2 is some X, right? Now what should I do? I should convert O2 molecule into its atomic state. I have to convert oxygen molecule into oxygen molecule into oxygen atom. That is exactly what we are doing here, right? Okay, fine. So now obviously for this reaction, whatever is this reaction is what is my bond enthalpy, isn't it? Right? Okay. Now this bond enthalpy, like I don't know the value yet, right? Now this bond enthalpy, we need to find this. This is what we need to find. So can I write this bond enthalpy is the overall delta HR for this? Is it not? This bond enthalpy is what is the overall enthalpy of the reaction for this reaction, basically. For this reaction, this and the bond enthalpy are going to be same, isn't it? So now I can write again this bond enthalpy in terms of your enthalpies of formation. You're getting it, right? This bond enthalpy, again, I'll be able to write in terms of what is that? Enthalpies of formation. Is it not? How will I go about it? Now, again, it's just simply going to be equal to enthalpy of formation of products minus enthalpy of formation of reactants. Can you tell me how am I going to go about it here? How will I write it here? Tell me, this bond enthalpy is equal to what? Or say delta HR for this reaction is equal to what? How will I write it in terms of enthalpies of formation?
Two into del HFO minus del HF of O2, sir.
Good, right? So it will be 2 into delta HF of oxygen. Why 2? Because I have stoichiometric coefficient of 2 minus enthalpy of formation of O2, which is
0, sir.
0. Good. That's it. Now, what we require is your bond enthalpy of O2, right? Now, I just require the enthalpy of formation of oxygen atom, and that we found out from the previous equation, if you can understand, from this equation, right? From this equation, right? So we found out, we just wrote it, the delta HR for this is given. Where is it? Delta HR for this reaction is given. So we wrote delta HR in terms of enthalpies of formation, enthalpy of formation of oxygen gas minus O2, which is 0, and minus enthalpy of formation of O3 gas. Enthalpy formation of O3 gas is given to us here, right? So we found out enthalpy of formation of oxygen gas from here. And what I need to find out is the bond enthalpy. We'll not be able to directly find it out, but how can I do it is, when I can write the bond enthalpy reaction. Bond enthalpy of O2 is equal. Now, how will I write the reaction? O2 gas gives 2 oxygen gas, oxygen atom. Correct? So obviously this is what is my bond enthalpy reaction. Again, for this reaction, I can write it in terms of your enthalpies of formation, right? And whatever the total enthalpy change for this reaction is, what is my bond enthalpy, right? So that is equal to 2 into delta, I mean, again, enthalpy of formation of products minus enthalpy of formation of reactants. So I have 2 into enthalpy of formation of oxygen gas minus 0. We found out the enthalpy of formation of the previous one. So I will be able to find the bond enthalpy, right? Understood? Yes? No?
Yes, sir.
Okay, what about others? Did you understand, people?
Yes, sir. Yes, sir.
Okay, cool. Right? So hope everybody understood. Like actually, what you should have done is you have started from this. If you started from this, maybe it would have been better. If you started from this, directly write this reaction, right? So basically, for you to find the bond enthalpy, the only thing which is required is enthalpy of formation of this oxygen gas, oxygen atomic gas, right? And obviously, you have to do the investigation to find out the enthalpy of formation of oxygen gas, atomic gas from the previous one, and that would have been easier. But now we just put it ulta. We did this first, and then we went for this. Correct, right? Anyways, we'll do another problem. Don't worry.
Sir,
Yeah.
What's the final answer for this, sir? I got
Fine.
498.4.
You got 498. 498.4 is correct. Yes, correct. Right. So you will see that enthalpy of formation of O would be 106.5 plus 142.7. Yeah, into 2 will be 407. Yeah, correct. It's correct. 498.4 is the correct answer. Yes, absolutely right. Okay. Now we'll do one more problem. Right. So now they have given right. So they have given enthalpy of formation of carbon disulfide CS2 is 117.36 kilojoules, right? And enthalpy of formation of carbon gas is given. See, I'm just writing this is also delta H of. Okay, fine. So enthalpy of formation of carbon gas is also given. That is my 716.6 kilojoules. And they have also given enthalpy of formation of sulfur gas, sulfur atomic gas. This is also carbon atomic gas. This is sulfur atomic gas is given to be 278.8 kilojoules, right? And what they ask is bond enthalpy of CS2 is what they're asking, right? So almost I would say a similar kind of problem from what we saw last time, right? So you have to find the bond enthalpy of CS2. Now I'll tell you how to go about, and you are going to do the problem, right? So you write the reaction for this, right? And obviously the overall enthalpy change will be what is my bond enthalpy, right? So that can be again equated in terms of your enthalpies of formation. If you do that, the problem is over. Please go for it and tell me the answer. I'll give you 2 minutes time.
Sir, they didn't give the equations, sir.
Sorry?
They didn't give the equations, sir.
No equations, no equations. You have to write the equation for this bond enthalpy of CS2. Okay, first question. How will you write the reaction for this bond enthalpy of CS2? Tell me.
I'm not sure, but I wrote as bond enthalpy of C plus 2 into bond enthalpy of S.
No, I'm asking, how will you just write the reaction? Just write the reaction for this. How will you write?
C plus S2 gives CS2, sir.
See, how do we define bond again? How do we define bond enthalpy? There is a molecule. You have whatever the elements present in that molecule has to go to atomic state. As simple as that, right? Okay. Now tell me, whatever it is, I have carbon, sulfur. They have to go to the atomic state. Now tell me, how will you write the reaction?
C plus 2S, sir.
Wait, which has to be there in the reactant side? What should be there in the reactant side for this?
CS2.
Good. CS2 should be there in the reactant side. Okay. Now this is the molecule. Now I have to convert it into atoms. What are the atoms? What are the elements present here? Carbon and sulfur. Now how will I write the atomic form?
C
How will I write the
plus
atomic?
2S, sir.
Correct. That's it. Carbon plus 2s. That's it. Again, everything should be in gaseous state. That's it, right? See, it's very, very straightforward, people. I think, I don't know why are you confused so much, right? Whatever the molecule you have, just convert them into atoms. Atoms means there is only one element, one atom present. That's it. No molecular forms. As simple as that. This, like, you talk about bond enthalpy, the molecule which you're going to speaking about should be there in the reactant side, and you look at the elements whatever present, and you just put them. That's it. You put them in the atomic state, single atoms. That's it. As simple as that. Yes. Okay. Fine. Now we have wrote the reaction, and obviously this is what is my enthalpy here. Delta HR for this reaction is what is my bond enthalpy, because we wrote the reaction for this only, isn't it? So I can write bond enthalpy or the delta HR for this in terms of, again, enthalpies of formation, isn't it? Right? Now go for it. How will you write it? Tell me. This in terms of enthalpies of formation, how will you write it? Look at the equation and tell me, how do you write in terms of enthalpies of formation?
Del HF of C plus 2 into del HF of S will give
del HF of C plus 2 into del HF of S. Okay, then
minus
minus
HF of CS2.
That's it. Right, del HF of CS2. That's it, right? As simple as that, right? So I have, these are the products, this is the reactant. I put 2 here because there is a stoichiometric coefficient of 2. And everything is given to you in the question. Is it not? Look at this. All these values are given to me in the question. So you just have to substitute and get the answer. Right? So hope everybody got it again. Right? See, like there is a lot of connection between all the enthalpies. Right? So whenever bond enthalpy is asked, mostly they'll be giving, like, you should write the reaction for that, and again that can be equated in terms of your enthalpies of formation. That is what these two problems tells you, right? So anyways, we'll practice more. You have to practice more. We will practice. Okay, so everybody understood, people? How do we go about this problem?
Yes, sir.
Okay, I want everybody to give me a yes, at least in the chat box. Oh yeah, Vanisha already gave the answer. C plus.
Yes, sir.
Okay. Bhavadarani says, very sorry, I had some problem with the no issues, Bhavadarani. Good that at least you joined from some other device. Good. Okay, fine. So everybody gave me an S. Right, good. We'll do another problem. Right. So do this problem. They have given.
What was the answer for the last one? Final
The
answer.
last question. You just have to calculate. So calculate. What is the answer you got?
Got 1156.84.
Yeah, 1156 point something. Yes, 1156 point something. Right. That's the kilojoules. Is the answer. Yes, correct. Cool. So next problem. Now they're asking when they have given bond energy or bond enthalpy of CH4 is given to be 360 kilocalories per mole, and also they have given bond enthalpy of C2H6 to be 620 kilocalories per mole, and what they're asking is bond dissociation energy of CC single bond. Hope you remember what is the difference between bond energy, bond enthalpy, and bond dissociation enthalpy, right? Can someone point out what is the difference between bond enthalpy and bond dissociation enthalpy? What is the difference?
Bond dissociation enthalpy, it is enthalpy change occurring when the bond is broken in a compound. So
Yeah. So the thing is, for bond dissociation enthalpy, we don't speak in terms of the whole compound. We speak in terms of one specific bond in a compound. Like how you're speaking here, you're saying bond, this is an energy of CC bond, and obviously in I have only one case where I have CC bond, that is in C2H6. In CH4, I don't have a CC bond, isn't it? So bond enthalpy, you can see you're talking in terms of the whole compound. Obviously, it is enthalpy of atomization. You have to convert the entire molecule into atoms, right? So, but bond dissociation energy will obviously be in terms of one particular type of bond, say CC bond or CH bond or OH bond, something like that, right? And when we looked at this, I told you how to connect your bond enthalpy with your bond dissociation enthalpies. Hope you remember that. So that is what we have to use here.
the number of bonds,
Exactly.
like for CH4 4
Okay,
into.
okay. Let me help you with this. Okay. So first let me take this one, bond enthalpy of CH4. Fine. How do you write the equation? Now, okay, I'm not gonna ask some random people. I'm gonna ask a specific guy or a girl. Okay, maybe I'll ask Venisha. Can you help me, Kana? How do you write this equation for bond enthalpy of CH4? They are given some value. Within your video is on. Okay, fine, it went. Right? Kana. Yes, can you tell me the equation? Like however you want to write it in the form, I will understand in the chat, don't worry. I hope you're typing. Yes, CH4 gives C plus 4H. Wonderful. Yes, Vanisha, absolutely right. Right. So as Vanisha said, how do we write the equation? Oh wait, full screen. Yeah. So I have CH4 gives. So this is my molecular form. I have to convert it into atoms. So 1 carbon atom and 4 hydrogen atoms. Yes. Okay. Very good. But this is not going to help us. The equation is not going to help us here because we are going to deal with in terms of bond dissociation energies. Okay. Now tell me, if this bond enthalpy is this much, bond enthalpy of CH4 is this much, there is only one type of bond here in CH4, that is my CH bond. Now, how will I equate it to bond? How will I equate it? How will I write this in terms of bond dissociation energies? Tell me. So basically, for this to happen, for this particular thing to happen, I have to basically break the bonds. What are the types of bonds I have to break? There is only one type of bond, that is your CH bond, right? How many CH bonds are there?
4, sir.
4 CH bonds. So how will I write bond enthalpy in terms of BDE? How will I write it? This is equal to BD. Okay, now you will tell me. Fine, I'll not write it. Yeah, tell me. So I told you. Yes.
4 into BDE of CH.
Wonderful, wonderful, absolutely right. So how will I write it? Bond enthalpy of CH4 is equal to 4 into bond dissociation energy of CH bond. Absolutely right. Right? So fine. Now we already know the value for bond enthalpy of CH4. So can I find what is the bond dissociation energy of CH? Yes. So it's only 360 by 4. So bond dissociation energy of CH is 90. Yes. Wonderful, right? Okay. Now tell me, in this case, when I have C2H6, how will I write it in terms of bond dissociation energies? So now you have two types of bonds here. Yes, what are the types of bonds?
Carbon,
C2H.
carbon, carbon, hydrogen.
Yes, that's it. CC single bond and CH single bond. Correct. Now tell me, how will I write it in terms of bond dissociation energies? Hope you remember the structure. It's CH3, CH. This is what is ethane, C2H6. Yes, how will I write it?
So what was the question again?
I'm asking, how will you write bond? Now, last time you wrote this bond enthalpy in terms of BDE. Again, for this, how will I write it in terms of BDE?
So 6 into BDE of CH
Good.
plus
6
2
into BDE of CH. Yes.
plus
Okay.
1 into BDE of CC. What?
That's it. Right. BDE of CC. Yes. So you can see there are 6 CH bonds. Right. So 6 into BDE of CH. And there's obviously one CC bond also present. So BDE of CH. Every bond has to be broken. That's it. Only then you'll be able to convert it into atoms. Right. So done. So what they're asking in the question, they're asking you what is the bond dissociation energy of CC bond? This is what is asked in the question. And this particular thing we found out from the last equation. And this bond total, this is equal to what? This is equal to the bond enthalpy that is also given to you. So you can easily find what is the bond dissociation energy of CC bond. Yes, right? Easy, right? So now I have 6 into this, 6 into 90 will become 540 minus whatever we have to find. X is equal to how much? Is equal to 620. So X would be equal to 540 minus 620, which will be how much? Minus 120 or plus 120?
80, sir. I
Sorry?
think minus 80.
Oh, this is plus, right? Why did I put a minus?
It should be
Plus.
80.
80, correct. X will be 80 kilocalories. Basically, X is what? X is my bond dissociation energy of CC bond. That's what we found out. 80 is the answer. Everybody understood,
Yes, sir.
Yes, sir.
right? Okay, fine. One more problem. I'm gonna pile you up with problems today. That's what we are gonna do. Okay, do this. Right. So they have given bond energy or bond enthalpy of OO double bond. Basically, OO double bond means O2, that we know, right? So is given to be 498.8 kilojoules per mole, right? And they have given the bond dissociation energy of OO single bond in O3. So obviously, in O3, I have one double bond O and one single bond O. Hope you remember that the structure, right? And that is equal to 302.3 kilojoules per mole, right? What is the, okay, now they're asking for this reaction. They have given me a reaction. So 3O2 gives 2O3 gas. So 2O2 gas gives me 2O3 gas. And they want to know
சாட்
delta
இதுல
H.
வாட்ஸ்அப்ல சாட்ல இல்லையா? நான் என்ன ஸ்டார்ட் பண்றது? ஒண்ணுமே இல்ல இதுல. நான் சும்மா எனக்கு நானும் என்னன்னா நானும் இப்படிதான் என்ன பண்றது? நான் உட்கார்ந்துட்டு இருக்கேன்.
Guys, I don't know who's that. I think you have to
வாட்ஸ்அப்
mute
ஒண்ணும் இல்ல.
yourself.
வந்து செக் பண்ணி பாத்துக்கோங்க. என்ன
Rahul. Oh, thank you.
Sir,
Right.
it was not me, sir.
Oh, who was it?
There are two Rahuls in the meet. I don't know who's that.
There are two Rahuls. What is that? How is it possible? As far as I know, it's only one Rahul is there. Okay, fine, whatever it is. There's no time for us to look into all this. Fine. So yeah, so they have given these two equations, I mean these two informations, and they have given you this reaction, and they're asking to find what is the enthalpy change for this reaction. Right. It's a pretty straightforward question if you just know what exactly you have to do.
We define del HR, sir.
Yeah, you have to find the enthalpy of enthalpy change for this reaction. So there is no other obvious. Okay, fine. Now, what do you think? How can we go about it? Any guesses? Okay, if I little change the question, maybe it will be little easy for you. Instead of
We can put
one second. Instead of bond enthalpy, I write it as bond dissociation energy of over double bond. Okay, now it makes sense. Now tell me, Rohan, what were you about to say?
So
Yes,
about
Rohan?
to say bond enthalpy of O double bond O is equal to the 2 into bond dissociation enthalpy of O single bond O.
No. That's what you cannot say. See, O double bond O is a completely different thing. O single bond O is a completely different thing. You cannot say that bond enthalpy of O double bond O is equal to twice the bond enthalpy of O single bond O. No, that's not how it works. I will have a different value for O single bond O, and I will have a different value for O double bond O. Okay, so you cannot connect. Just like that, you have different enthalpies for C single bond Cs and C double bond Cs. But it will not be twice the value. It will be definitely greater than C single bond Cs, but it will not be exactly twice. That way you cannot work. Right? Now, okay, any other way anybody thinks of to finding this? So you don't have to give me the exact total number of what are the exact steps you have to do, but how will you approach it is what I'm asking.
So we have to find bond enthalpy of both.
Yes. So obviously you know that I can write enthalpy of a reaction in terms of bond enthalpies, BEs. Correct? How will I write it? Forget about this reaction. I'm just generally asking enthalpy of a reaction. How will you write it in terms of bond enthalpies? We spoke about this, right? There are three ways by which you can talk about enthalpies of reaction. One is in terms of enthalpies of formation. The second is in terms of enthalpies of combustion. Third one is going to be in terms of bond enthalpies. Yes? Now I'm asking you, how will you write enthalpy of a reaction in terms of bond enthalpy? How will you write it?
The bond enthalpy of reactant minus bond enthalpy
Yes.
of product, sir.
Absolutely. Right. Now tell me, so delta HR for this reaction, how will I write it in terms of bond enthalpy? So you just told me that it is bond enthalpy of reactants minus total bond enthalpy of products. Right? Now tell me, how will I write it?
Total bond enthalpy of O2 minus total bond enthalpy of O3.
Total bond enthalpy means what? Like this is a specific reaction. So you have to, what do you mean by total? There is only one reactant, one product. That's it. When I say total, if I have more than one reactant or more than one product, I have to sum it up. That's what I mean by that.
Yes, sir.
So how for this reaction, how will you write?
Bond enthalpy of O2 minus
That's it. No numbers.
3 into bond enthalpy, sir.
Correct. So 3 into bond. Oh, wait. 3 into bond enthalpy of O2. Okay. Then
minus 2 into bond enthalpy of O3.
Yes, minus 2 into bond enthalpy or enthalpy of atomization of O3. Okay, done. Fine. Right. Now, obviously, bond enthalpies are not directly given to us. Correct. But I will be able to find what is the bond enthalpies. Right. Obviously, what is given to you? Bond dissociation energies are given to you. Correct. Right. Fine. For bond enthalpy of O2, obviously I know the structure. It's basically going to be O double bond O. Right. Now, if I write this in terms of for both these bond enthalpies, write it in terms of bond dissociation enthalpies. How will I write? First, we'll just come back to this. Now, tell me bond enthalpy of O2 in terms of bond dissociation enthalpy. How will I write?
1 into bond dissociation enthalpy of O double bond O.
Exactly, right? So I have only one bond to break, that is my O double bond O. That's it. Very, very simple. So bond enthalpy of O2 is basically going to be equal to bond dissociation energy of OO double bond. Done. Okay, now I'm going to ask someone specific. Maybe I will ask Abhishek, are you there, Kana? Put it in the chat box. Yes, you're there. Cool. So I'm asking you for bond enthalpy of ozone, how will you write it in terms of bond dissociation enthalpies? Okay, if you want the structure of ozone, this is what is the structure of ozone. Okay, I have one O double bond O and one O single bond O. Yes, how will you write it? Maybe put it in the chat box. I don't know, maybe. Yes, Abhishek, are you still thinking? Abhishek?
Sir, can you show the screen properly, sir?
Sir,
Yeah,
actually,
sure.
the first two lines, it is difficult to understand the handwriting, sir. after
Which
the
first two
DT,
lines?
yes, sir, the where you like do the curly brackets.
Oh, here.
I'm not able to understand that 0 is equal to 0 or what is that, sir? Yes, sir. The two
This
lines,
one.
it is difficult. Yes, sir.
Oh, nothing. Bond dissociation energy of O double bond O, some number is there, and bond dissociation energy of O single bond O, some number is there. Bond O single bond O and ozone O3 is some number, say not 2.3. And they have given the question for this reaction, find out the enthalpy of the reaction. That's it. We wrote enthalpy of the reaction in terms of bond enthalpy of reactants minus bond enthalpy of products. Now we did bond enthalpy of O2 in terms of bond dissociation energy. We wrote it as bond energy of O2 is equal to bond dissociation energy of O double bond O. What I am asking is bond energy of O3. Yes, tell me.
Sir, bond dissociation energy, O triple bond O.
O triple bond. Do I have this anywhere here in this ozone? Look at this molecule. Look at the structure and tell me properly.
Oh, okay, sir. Okay, sir. I did not see that.
Yeah.
Sir, I just have a question, sir.
1 second. Let him complete. I can ask it.
Sir, O single bond O.
What? O single bond O what?
Double bond O.
No. Tell me properly. BDE of what? What are the bonds you have to break?
O double bond O2, sir.
No. See, answer my simple questions. I have one O double. Okay, right. I have one O single bond O, and I have one O double bond O. Right? Both these bonds has to be broken. Correct. So now tell me how do I write it? BDE of? Now last time how you wrote? I have only one O double bond O, so I broke it. BDE of O double bond O. Now I have one thing extra also. What is the extra?
Single bond O.
So now tell me how will I write the equation? How will I write this DE in terms of BDE? Yes, what you said is correct. O2 mean O double bond O plus O single bond O. But just like that I have to write, or I have to include this BDE also. Okay, fine. Abhishek, let me ask someone else. Maybe I hope Shruti is there. Shruti, are you there?
Yes, sir.
Can it 1 second? Can you tell me how do you write this? Bond energy of O2 will be equal to, sorry.
1 into BDE of O double bond O plus 1 into BDE of O single bond O.
That's it. Very simple. Abhishek, understood? You have to break one double bond O and one single bond O. BDE of O double bond O plus BDE of O double bond O. Yes, Rohan, ask your out.
Is the final answer in negative, sir?
Final answer is negative. What is the answer you're getting?
I got minus 105.8.
No, not exactly. Right? So anyways, we'll try to do this. Okay, fine. So we have done bond energy of O2 is done, bond energy of O3 is done, and I have to substitute it here. That's it in this equation. They're asking you what is the enthalpy change for this reaction, 3O2 giving 2O3, right? So now how will I write it? I think, okay, let me rub this, the first two these things, so that I'll have space to write, because I don't want to change the page. Okay, right. So now how will I write it? Delta HR for this reaction, right, will be equal to, we already wrote it, right? So we just have to write it in terms of BDE now. So first is bond enthalpy of O2. So it will be 3 into BDE of O double bond O, right? Okay, that's done. What I have next? I have minus. Next, I have 2 into bond energy of O3, and bond enthalpy of O3 is equal to this total one, bond energy BDE of O double bond O plus BDE of O single bond O, right? So now how will I write it? 2 into BDE of O double bond O plus BDE of O single bond. Yes, that's it. Everything is given to us in the question. BDE of O double bond O is given. BDE of O single bond is also given. So you just have to get the equation right. Right. So the final, if you just substitute it, the final answer I'll tell you now. Okay. So answer is a positive answer. The answer is 286.8 kilojoules is the final answer. Right. So hope everybody understood how did we go about it, right? So what you just did the small thing. You just connected your bond enthalpies with your bond dissociation enthalpies. That's it, and you just substituted. As simple as that. Yes, everybody understood?
Yes, sir.
Okay, right? Fine. So we will do some more problems because I feel you're not ready yet. Like so many people are still struggling. Like not, I would say, but it is completely all right. This is a little complicated. These things, right? So, anyways, I'll make you ready, right? By I think next class also, if we do some good number of problems, you will be perfect. Don't worry. Okay. So I think we'll stop with this for today, right? So next class, yeah. Tell me, Kanna.
So I'm getting bond enthalpy of O3 as higher than bond enthalpy of O2, sir.
Definitely, right?
And when I
Definitely.
calculate, it's coming higher, sir, for me.
No, obviously bond enthalpy, bond energy of O3 will be greater because you have to break O double bond O as well as O single bond O. Definitely it will be greater.
No, sir. I mean, like the final answer is coming in negative for me.
Yes.
Final answers coming in
Minus
negative.
115.8 I'm getting, sir.
Oh, okay. So what is going wrong then? 3, we did correct, right? Delta HR will be equal to 3 into bond enthalpy of O2 plus minus 2 into bond enthalpy of O3. Okay, this is okay. Everything is okay. Maybe the book answer is wrong then, right? But what we did is exactly correct. So if you just followed what we did, whatever the answer you got should be correct. Okay,
sir.
Right? Because we didn't do we did everything correct. Everything is perfect here. Okay, right? So yeah, thank you, people. We'll meet again. I think day after tomorrow, right? But again, this week also you will have an extra class maybe on Thursday, right? Because we missed 2 classes, I guess. Fine. So we'll look into it, what we can do. Right. Okay. Thank you, guys. We'll meet again.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you.